This is very important 2-mark question and 3-mark question also. Faraday's laws. 2 laws are there. So Faraday first law and Faraday second law. First law means whenever there is a change in magnetic flux, the change in magnetic flux linked with the closed circuit and induced EMF produced. Whenever there is a changing magnetic flux, the change in magnetic flux linked with the closed circuit, what happens means they produce induced EMF. This is Faraday first law. Suppose I will give the experimental verification or diagram means, see that I have taken a coil. The coil is connected by the galvanometer, positive, negative. I will take a small bar magnet. Whenever there is change in magnetic flux, that means the magnet produce magnetic lines. The magnetic lines crossing the coil. How that crosses means it is converted into magnetic flux. See that the magnetic flux, the magnetic lines crossing the coil or entering the coil, it is converted into magnetic lines. Entering the coil means magnetic flux. So this is magnetic lines. What is this means? After the coil called as magnetic flux. The magnetic flux, whenever there is a change in magnetic flux. How to change means, see that the magnetic flux here small line and next magnetic lines move little bit more compared to first line, and third magnetic lines converted into magnetic flux, it move in the little bit compared to first and second, it is a longer length line. That means magnetic, there is change in magnetic flux. Whenever there is change in magnetic flux linked with the closed circuit, they produce induced EMF. What they produced? Induced. Got it? Induced EMF. Next, Faraday's second law. What is Faraday's second law? Means the magnitude of the induced EMF. What is that? The magnitude of the induced is directly proportional to rate of change of magnetic flux. What is that? Rate of change of the magnitude of the induced EMF is directly proportional to the rate of change of magnetic flux. Change of magnetic so we can write the mathematical expression for this step. See, the magnitude of the induced EMF. Previous year the EMF symbol is E, but the new book changes. No, that time they changed the symbol also. What is that symbol? The EMF represented by small e, otherwise psi. So the induced EMF is directly proportional to rate of change of magnetic flux d pi by dt. This is called the rate of change of magnetic flux. The induced EMF, that means the magnitude of the induced EMF directly proportional to the rate of change of magnetic flux. This equation I will equal means pi equal to minus n d pi p by dt. Here what that n indicates? N indicates the coil is there, no? The coil, how many number of turns? We don't know that 10 or 20 or 30 or 500 or 5000, 20,000. That's why we can use that n. Here n indicates the coil containing number of turns. What is that? The coil containing number of turns. And the negative sign indicates the direction of flow of induced current. The direction, the negative sign indicates direction flow of induced current. Now you all are getting a clear idea what is Faraday's laws. Faraday, two laws are there. One is Faraday first law, another one is Faraday second law. Faraday first law indicates whenever there is change in magnetic flux linked with the closed circuit, they produced induced EMF. This is first law. Second law, the magnitude of the induced EMF is directly proportional to the rate of change of the magnetic flux. This is a theoretical statement. When we write the mathematical expression, we are denoted by the induced EMF E in the old syllabus, but in the new syllabus they are denoted by the symbol psi. The induced EMF is directly proportional to rate of change of magnetic flux, that is d pi by dt. Here negative sign indicates the direction of flow of induced current, and another equation psi equal to minus n d pi by dt. Here what is n indicates means n indicates the coil has number of turns, maybe that is 5, 10, 20, 500, 5000, whatever that. So we are using n number of turns. That's why here minus n d pi by dt. Okay. So just we recall what are the topics we are covered means magnetic effect of electric current, isn't it? Magnetic effect of electric current. Actually this is our third lesson. Just I recall this topic. Next magnetic flux. Next, Faraday law of electromagnetic induction. Faraday law of electromagnetic induction. Faraday law of verification. Faraday law experimental verification. Next, definition of electromagnetic induction, and next Faraday's laws. These are the topics we covered. If you have any difficulty for this topic, please contact me. Next, we are going to discuss about the Fleming right hand rule. Fleming right hand rule, already in our previous chapter, third lesson, magnetic effect of electric current, we have discussed Fleming left hand rule, and this chapter, electromagnetic induction and alternating current, we are going to discuss about Fleming right hand rule, and also we studied, I hope you studied 10th standard itself, Fleming left hand and right hand rule. Here we are going to discuss Fleming right hand rule. What is that? Fleming right hand rule. First, we'll discuss Fleming right hand rule. Next, we recall that Fleming left hand rule. Okay. So, Fleming right hand rule. Take our right hand, stitch the three finger in our right hand. See that? Thumb, forefinger, and middle finger, or thumb, index finger, middle finger, like that. Three fingers are mutually perpendicular to each other. What is that? Three fingers are mutually perpendicular to each other. What are the fingers I will take in our right hand? Three fingers. What are that? First, forefinger or index finger. Second, thumb. Next, third finger is middle finger. So, three fingers are mutually perpendicular to each other. See that? Thumb is perpendicular to forefinger, and forefinger is perpendicular to thumb, and forefinger is perpendicular to middle finger, and middle finger is perpendicular to index finger. So, three fingers are perpendicular to each other. So, forefinger indicates, or index finger indicates the direction of magnetic field. What is that? The direction of, what is that? Magnetic field. And thumb represents the direction of motion of conductor. The direction of motion of the conductor. And middle finger indicates the direction of induced current. What is that? The direction of induced current. So once again, I recall the Fleming right hand rule. Stitch the three fingers in our right hand, mutually perpendicular to each other. What are the three fingers? Thumb, forefinger, middle finger. Here, forefinger indicates the direction of the magnetic field, and thumb indicates the direction of the motion of conductor, and middle finger indicates the direction of the induced current. This Fleming right hand rule we will use in the dynamos, AC generator, DC generator. Next, it is nothing but based on the electromagnetic induction. Next, already we have discussed Fleming left hand rule. Just I recall Fleming left hand rule. What is that? Fleming left hand rule. Take our left hand, stitch the three fingers mutually perpendicular to each other. Right hand means right hand will take. Left hand means left hand, stitch the three finger and mutually perpendicular to each other. Thumb, index finger and middle finger. Here, first we will use that forefinger or index finger. Second, middle finger. And third one is thumb. This is the difference for right hand and the left hand rule. Right hand rule we will use forefinger, thumb, then middle. Left hand rule, index finger middle finger, then thumb. So here also, index finger shows the direction of magnetic field, just represented by magnetic field B, and middle finger represented by the direction of the current. What is that? Direction of the current. And thumb represented by the motion of the conductor. Direction of the motion of the conductor. So just you will get an idea what is the difference in the right hand rule and left hand rule means. If you will see very closely, here the middle finger shows the direction of induced current, but here the middle finger shows the direction of the current, not the induced current. Here current. That means on this rule is used. Fleming right hand rule used in the generators. But Fleming left hand rule used, one more question, Fleming left hand rule used electric motors. Where is that? Electric motor. So if they will ask one more question, Fleming right hand rule used generators, Fleming left hand rule used electric motors. Okay, and write the difference between Fleming right hand and left hand rule. Fleming right hand rule produce induced current. Fleming left hand rule produce the direction of the current only. Okay, so these are the topics we covered today. Just what you will do means you will take down the notes and write and see individually. Today we are going to discuss about Lenz's law. Before we are going to discuss about Lenz's law, just to recall that the electromagnetic induction, the definition of electromagnetic induction. Whenever there is change in magnetic flux, the change in magnetic flux linked with the closed circuit and EMF is produced. Due to the EMF, induced current is generated in the circuit. This phenomena is known as electric current. We can write the equation part means, see that EMF psi equal to minus d pi d by dt. In previous class, so Lenz's law. What is the main use of Lenz's law means? To find the direction of induced current. What is that? To find the direction of what current? Induced current. Find the direction of induced. We have to use to find the direction of the current right hand rule also, or right hand thumb rule, right hand thumb rule. But here Lenz's law is there, better to find the direction of the. What is the main aim of Lenz's law means? To find the direction of induced current. Okay, so how to find the direction of induced current means we can use the Lenz's law. And Lenz's law is also important. One more question is also known as conservation of energy. What is that? Conservation of energy. Why it is called conservation of energy? We will discuss later. Okay, so how to find the direction of induced current means we can use Lenz's law. First we will see that what is the Lenz's law. Lenz's law states that, see that, you also recall my statement. Lenz's law says that the direction of the induced current, what is that? The direction of the what current? Induced the direction of the induced current in such that always oppose oppose the cause responsible for its production. What is that? Responsible for its production. I will explain. This is a statement. How that what is cause, what is production, everything I will explain. So Lenz's law, use that to find the direction of induced current. First we will see that statement of the law. The Lenz's law states that the direction of the induced current is such that always oppose the cause responsible for its production. Responsible for its production. Here what is cause and what is production? See that? Cause and production is nothing but we call effect. According to Faraday's law of electromagnetic induction. According to Faraday's law of short form electromagnetic induction. What is that electromagnetic induction? Says whenever there is change in magnetic flux, the EMF is induced. That means induced current is produced on the closed circuit. So here cause is the magnetic flux. What is that? Cause magnetic flux. Change in magnetic flux. What is the effect? Means effect is the production. What here production? Induced current, isn't it? The induced current always oppose. What they oppose means change the magnetic flux or increasing the magnetic flux or decreasing the magnetic flux. This denoted by the Lenz's law. This is the cause and the effect. How that the induced current oppose the cause or generate the or decreasing the or increasing the magnetic flux. We will see the experimentally. So once again, Lenz's law used to find the direction of induced current. Statement of Lenz's law states that the direction of the induced current in such that always oppose the cause responsible for its production. Here production means electric current. Cause means magnetic flux. According to the Faraday law of electromagnetic induction, we will discuss what is the cause, what is the effect. Here cause is the production of change in the magnetic flux, maybe that is increases or decreases. Effect is the induced current. This induced current always oppose the change in magnetic flux or increasing the magnetic flux or decreasing the magnetic flux. How means